Good morning everybody, welcome back to Data Structure Laboratory. In today's class we will see third data structure lab experiment. Let me read out the problem statement. Design, develop and implement a menu driven C program to perform following operations on stack of integers. First one, push an element onto the stack, that is we are going to add a new item into the stack. Second operation, pop an element from the stack, that is we are going to delete an existing item from the stack if items are there in the stack. Third, demonstrate how stack can be used to check for the palindrome. We already know what is palindrome. For example, if the number is 121, if you reverse it, it becomes 121. So the original number and reversed number both are same. It is a palindrome. If the number is 123, if you reverse it, it becomes 321. So original number and reversed numbers are not same. It is called as not a palindrome, right? So with this problem statement, let me start with the program. So before we start with the lab program, let me just tell you how the push and pop operation can be done. So basically stack is a vertical implementation of array. We will have only one end. From the same end we can insert an item. From the same end we can delete the item. So whatever item you add first in the stack, it will be deleted only last. Hence it is called as last in first out data structure or first in last out data structure. So when I take a stack with a size 3, initially this is how it looks like. Top is the only index location which will be pointing to stack. So initially top index value will be pointing to -1. When the top is pointing at -1, we say stack is empty, completely empty. Let us assume that I want to add a new item called 1. If you want to add a new item called 1, you first check whether stack is overflow. So is it overflow now? Is it full? No, because none of the items are there. What is the total size of the stack? It is 3. It means that we can add 3 items. So I have just checked whether stack is overflow. How I'll check it? Whenever all 3 locations are full, then top will be pointing at 2, which is size -1. So when top is pointing at size -1, we call it as stack overflow. So now initially no items are there, so stack is not full. I'll increment top by 1. Top points at 0th location. At this location I'll add a new number, that is 1. Okay. So push operation is executed where 1 is inserted into the stack at a location 0. Now let us say I want to insert one more item into the stack. I'll now check whether stack is full. So where top is pointing, it is pointing at 0. So it is not size -1. Hence it is not full. When it is not full, you increment top by 1. Top points at first location. At this item you can add 2, right? So again I can insert one more item because one more location is free. Okay. So if I want to add one more item, I'll just check whether stack is full. So where top is pointing at a location 1, which is not size -1. So stack is not full. So I am going to read a new item and I am going to store at a location 2, right? So 3 items are already added into the stack. First item is present at 0th location, second item at first location, and third item at second location. If I try to add one more item, since top is pointing at size -1, which is 2, it will say that stack is overflow and you cannot add further any item into the stack. Okay. So by incrementing top, we push an item into the stack. If I want to delete, which item will be deleted? The topmost item will be deleted. What is the number? It is 1. So after deleting it, I'll decrement top by 1. Top points at first index location. Then the 2 will be deleted. Then I'll decrement top by 1. Top points at 0th location. I'll delete the first item, right? So after deleting the first item, top will point to -1. Now the stack will be empty, right? So whenever top is pointing at -1, stack will be underflow or empty. Whenever top is pointing at size -1, then the stack is overflow or full. Okay. So with these two functions, Let us start with the lab program. They have taken, in this lab program, we have taken a max size of a stack as 3. We will declare a variable stack of max size. So stack size becomes 3. The only index location which points at stack is top. So we will initialize top to -1. So what is the initial value of top? It is -1. That is this one, the first vertical implementation, right? So what are the functions we are going to implement? We are going to implement push, pop, display, and then palindrome. When you see these functions, it is like these are the functions which do not read any arguments and which do not return any of the input data. That is the reason why we have void. Void means these functions will not return anything, and argument is nothing, so they do not take any argument. So it is a first very simple implementation of function, right? So let me start with the main program directly. When you compile and run this program, you will get something like this. It will display a content on the screen like this: stack operations, 1 for push, 2 for pop, 3 for display, 1 for push, 2 for pop, 3 for palindrome, 4 for display, 5 for exit. It will ask enter your choice. So if you press 1, what happens is it calls push, right? When you press 2, it calls pop. This one, case 2 will be executed. When you press 3, palindrome will be executed. When you press 4, display will be executed. When you press 5, it says, it just terminates the program. If you press any of the values other than 1 to 5, it says invalid choice, right? So this is how the main program looks like. So what is the content of the main program? Just display the menu, ask the user to select any of the operation by pressing either 1, 2, 3, 4, 5. That's it. So let us start with the push operation now. The first operation is push. Push indicates we are going to insert a new item into the stack. As I already mentioned, when you are trying to add a new item into the stack, you are going to check whether stack is overflow or not. If it is overflow, you cannot add any item into the stack because there will not be any space. So how do you check it? If top is pointing to max size -1, print stack overflow, else. Now say if it is not overflow, what is the thing I am going to do? You just print a message on the monitor saying enter the element to be inserted. So whenever this message is displayed on the monitor, I'll press 1. 1 is the first item to be added into the stack, right? So how do you add this item into the stack? Increment top by 1. Earlier top was pointing to -1. When you say top equal to top plus 1, top will point to 0th location. Now item contains 1. This item will be stored in stack of top. So what is the location of top now? 0, right? So whenever you press 1, what happens is it will check whether stack is overflow. If it is overflow, it prints stack is overflow. Otherwise, it will ask the user to enter a new item, increment top by 1, insert the item into the stack. So very, very simple. How do I push the item into the stack? Just increment top by 1. Whichever location top points, at that location you can store a new item. That's it. So this is push operation. Okay. Now let us start with the pop operation. What is pop? Deleting an existing item from the stack. So when you want to delete an item from the stack, what is the condition you have to check is you should have at least one item in the stack. Yes or no, right? So if you have item, you can delete. If you do not have item, you cannot delete anything. So how do you check stack is empty? If top is pointing to -1, print stack underflow, right? If this condition is not true, come to else. Which item you are going to delete? The item which is pointed by top. So I'll say stack of top. So where top is pointing right now, it is pointing at a location, last location. So what is the item which is there in that? 1. So take that 1, store it in the item, decrement top by 1, top will point to a previous value, that is 2, right? Okay, then you display the item to be deleted. What is the item that is deleted now? 1. It says the popped element is 1. So wherever top is pointing, that location will be deleted. That location's item will be deleted. So how do you perform pop operation? Check whether stack is underflow. If it is not underflow, take the item pointed by top, decrement top by 1 and print that item. That's it. So this is pop operation. Next operation is palindrome, right? Now what is the content which is there in the stack now? The content which is there is this one. We have something called, see, this is what we have right now. So what is the content of the stack? I have something called so this is what I have. Right. So let us assume that I have 1, 2 and 1. So this is a content which is there in the stack, right? So this is a content which is there in the stack. So when you add 3 items, top will be pointing to the topmost item, that is 1, right? Now I have to check whether it is palindrome or not. Since the number is 1 to 1, if you reverse it also you get 1 to 1. So it is a palindrome, right? So let us understand how the function palindrome will check whether it is palindrome or not. So we have taken a content of the stack. The first thing what we do is we are going to copy all the elements from the stack to the array called num, right? So how I'll copy it? I'll just take, see, whichever item which is pointed by top. Where is top now? It is pointing at 1. Copy that 1 into 0th location of num. So 1 comes here. Decrement top by 1, top points at 2. Copy that to first location of num. Decrement top by 1, top points at 1 and copy that 1 to the second location of num, right? So in a reverse way, I am going to copy all the items from stack to a single dimensional array called num. So I will get something called as 1, 2, 1. So how I am going to copy this content now? See, there is a while loop, right? So what this while loop does, where top is pointing at a location 2, right? It is not equal to -1, condition is true. Take that item pointed by top, store it in a digit. That digit you store it in num of I. What is I value? 0, right? So 1 gets copied at 0th location of num. Decrement top by 1, increment I by 1. So I will go to 1, top will come to the previous location, that is 2, right? Since it is while loop, again the control comes back here. Top is pointing at a location 1, 1 is not -1. Take the content of top. What is the content of the top? 2. Store it in a digit. Same digit you can copy it into num of I. So 2 comes here. Next, decrement top by 1, increment I by 1. So top will point at 1 and I will point at 2, right? Since it is a while loop, top is 0, 0 is not equal to -1. Take stack of 0, store it in digit. Same digit you can store it in num of 2. So I will get 1 stored at num of 2. Decrement top by 1, increment I by 1, top points at -1. So this while terminates. So what is the use of this while? Just copy all the content from the stack in a reverse way to a single dimensional array called num. So I will get 1, 2, 1 in the array, right? Now let us see the next operation. What is the next operation is, we are going to copy all the numbers. See, what is all the numbers now? What is the original number? 1, 2, 1. So copy these numbers in a reverse way to reverse. So I'll take this 1, copy at a first location. I'll take this 2, copy at a next location. I'll take this 1 and copy it at the next location, right? So I have to start copying all the elements from the array num in a reverse way to a array called as reverse, right? So how to copy this now in a reverse way? Let us see. This is take a index value k, make it point to len minus 1. What is len minus 1 now? It is 2, right? 2 is greater than equal to 0. Take a num of 2, store it in reverse of 0. What is k value? K value is 0, right? So when you do this, what happens is the last number of num, which is 1, gets copied at first location of reverse, correct? So since it is a for loop, k decrements, index increments, again say k value is greater than equal to 0, num of 1 copy it to reverse of k, increment index and decrement k, right? So the second location number from num get copied into next location of reverse. Decrement k by 1, k becomes 0. 0 is greater than equal to 0. Copy num of 0 into reverse of 2, increment index. Then after decrementing k, k becomes minus 1, this for loop terminates. So what this for loop does is, it will copy all the numbers from num from last location to first location. That is, 1 gets copied to 0th location of reverse. This 2 gets copied to first location of reverse, and 1 gets copied to second location of reverse, right? So what we have done is, the first while loop copies all the content from stack into num, and next for loop copies all the values from num into an array called reverse, right? Now we are going to jump into a last part of the palindrome checking. So how do we check whether the number is palindrome or not? Just print what is a reverse number, okay? So here I am going to print what is the original number with a for loop, right? For j equal to 0, j less than len, j plus plus, print all the original number. So what is the original number now? Num of 0 is 1, num of 1 is 2, num of 2 is 1, right? So original number is 1, 2, 1. After reversing, again we are going to print a reversed number. Take another for loop and print all the reversed numbers, right? What is the reversed number now? Original number is 121 and reversed number is also 121. Clear? Now we have to check whether each digit from first array and second array, are they same or not, right? How many values we have in each array? 3 values. So come to first index, check whether they are same. If they are same, go to second location, check whether they are same. If they are same, go to third location, check whether they are same. This is what we have to do. The same thing is done here. You can see this is the last part. So where is first location stored? First character is stored 0th location. Say I is 0, num of 0, is it equal to reverse of 0? Yes. Num of 0 is 1, reverse of 0 is also 1. Condition is true. Increment length by 1, length becomes 1. I increments, I becomes 1. Num of 1 is also 2. Reverse of 1 is also 2. Both the numbers are same. Increment length by 1. I increments. Num of 2 is 1. Reverse of 2 is 1. So again the condition is true. Increment length by 1. Now let us assume that the original number is 121 and reversed number is 123. See, first character matches, length becomes 1. Second character matches, length become 2. But third character do not match, length will not be incremented. If it is 121, 121, see what is the length we will have? It is 3. How many numbers we have? 3. So whenever length variable is equal to size of the original number, we say that all 3 characters, all 3 digit match, right? So whenever length is equal to length, you can print it is a palindrome. Otherwise, you can print it is not a palindrome, right? So this is the last operation the most important operation, that is palindrome. The last function is a display function. You know, this is how the stack looks like. Either you can go on printing from 0th location to second location, or second location to 0th location, either from bottom to top or top to bottom. Anything is okay, right? So before displaying the content, first check whether stack is empty. How do you check stack is empty? If top is -1, print stack is empty. Else take a for loop. So here they are going to display from top to bottom. So what is I value? It is pointing at top. What is top? This location, right? So which location it is? Second location it is. The 1 is stored at 0th location, 2 is stored at first location, and 1 is stored at second location, right? So I is pointing at 2. 2 is greater than equal to 0. Print stack of 0. Print stack of 2. What is stack of 2? 1. Decrement I by 1. I becomes 1. 1 is greater than equal to 0. Print stack of 1. What is stack of 1? 2. Decrement I by 1. I becomes 0. 0 is it greater than equal to 0? Yes. Print stack of 0. Then again decrement I by 1. I becomes -1. -1 is not greater than equal to 0. So stop it, right? So we are going to print all the numbers from top equal to 2, then 1, then 0, then we stop, right? So this is the third lab experiment. You can just copy this and run. You will get the output easily, right? Thank you so much.